We often think of AI as this one giant, all-powerful brain, right? But what if that's not the best way to do it? It turns out some of the most reliable AI products out there are actually doing something totally different. They're building teams of specialized AI agents that work together. So, let's dive into this architectural choice, the powerful but sometimes perilous world of multi-agent AI. Okay, so let's start with a real-world problem that you've probably faced. Look at this. My flight is delayed 3 hours and I'll miss my connection to Tokyo. Can you rebook for me? Now, a simple AI, it can tell you your gate number in a snap. But when you throw it a curveball like this, a complex multi-step request that needs actual problem-solving across different systems, well, that's where things can really start to fall apart. So, what happens next? Well, a single agent trying to be a jack of all trades gets totally overwhelmed. It's juggling logistics, booking systems, your preferences, and it just loses the plot. The result? It offers you a new route with get this, a 14-hour layover. No thanks. But a team of agents, oh, that's a different story. You've got a logistics agent that flags the delay, a booking agent immediately starts searching for new flights, and a policy agent checks the rules for your upgrade. They all talk to each other and coordinate to find a much better solution, one that the single, overworked AI would have completely missed. And that right there, that success story, brings us to a fundamentally different way of thinking about AI architecture. Instead of relying on one single model to do everything, we build a team. So what exactly is a multi-agent system, or MAS for short? Well, it's pretty much what it sounds like. It's a system that takes a big job and distributes it across specialized agents. All those tasks that would totally overwhelm a single model, they become way more manageable when you have teamwork and focused expertise. To make this really hit home, let's use an analogy. Imagine a busy restaurant kitchen. You could have just one cook, right? Trying to prep all the ingredients, work the grill, and plate the desserts at the same time. The result? Absolute chaos and probably pretty mediocre food. Or you could have a specialized team, a prep cook, a line cook, a pastry chef. Suddenly, orders are flying out and the quality is way, way higher. All because everyone is focused on what they do best. That right there is the core idea behind multi-agent systems. Okay, so we get the what. Now, let's dig into the why. What are the actual benefits here? What's the big promise that makes this approach so compelling? Benefit number 1, and this is a big one. Specialization just beats generalization, hands down. Think about it. When you have a dedicated billing agent, its whole world is financial data. An order tracking agent, it lives and breathes logistics. This intense focus dramatically reduces errors and those weird AI hallucinations, where it just makes stuff up because the agent isn't constantly trying to switch gears between a bunch of unrelated jobs. Alright, the second huge advantage is validation. A single AI model has like zero self-awareness. It has no way to check its own work. It can tell you something that's completely wrong with 100% confidence. But when you have multiple agents, you can build in a peer review process. It's just like having a coworker look over your shoulder at a report. They're going to spot mistakes that you are totally blind to. And here's how that peer review actually works in practice. Let's say one agent, the generation agent, creates a financial report, but it doesn't just go out. Nope. First, a logic agent steps in to check the reasoning. Then a fact agent cross-references the numbers against the database to make sure they're real. And finally, a safety agent gives it one last look to ensure everything is appropriate. The system literally self-corrects before you, the user, ever see a potential mistake. It's pretty cool. The third big promise is all about speed, especially at scale. A single agent has to trudge through a massive list of tasks one by one by one. It creates this huge bottleneck. But a multi-agent system can take that giant workload, chop it up into smaller pieces, and have multiple agents process everything at the same time. And this isn't just theory. The practical advantage is massive. Check this out. Analyzing 500 customer reviews might take a single agent a full 20 minutes. But with a multi-agent setup, a dispatcher can split that work across, say, 10 different analysis agents. Each one only has to handle 50 reviews, and they finish the whole job in just 3 minutes. That's not just a little speed boost. That is a complete game changer for what's even possible. Okay, so at this point you're probably thinking, wow, these systems sound amazing. Why isn't everyone using them? Well, this is where we hit the reality check. Because the very same collaboration that makes these systems so powerful also introduces a massive and often hidden cost, the cost of coordination. Which brings us to a really critical question. If these systems are so powerful, why do so many projects fail? I mean, Gartner predicts that a whopping 40% of these kinds of AI projects will be cancelled by 2027. So, what's going on? It's not the agents themselves. They usually work just fine. The real problem is getting them to work together. This coordination problem tends to break down in 3 big ways. First off, memory gets totally fragmented. Each agent is in its own little bubble with its own context, and trying to share just the right information between them is incredibly hard. Second, your operational costs just multiply. All those handoffs, all that verification, it adds up. And third, what happens when multiple agents try to write to the same file or database at the same time? You get what are called write conflicts, and things can cascade into absolute chaos fast. So here's the bottom line, the crucial point. All that extra communication, all that context sharing, all those verification steps, none of it is free. In fact, a multi-agent system can easily cost you 2 to 5 times more than a single-agent approach for the exact same task. And that's the trade-off that catches so many projects completely by surprise. So, okay, we know the incredible benefits, but we also know the very real costs. How in the world do you decide if this kind of architecture is actually right for your project? Well, here's a simple 5-question framework you can use. Question 1. Are you absolutely sure you can't solve this with just better prompt engineering? Seriously, try that first. 2. Are your subtasks genuinely independent, or do they constantly need info from each other? 3. Can your budget really handle that 2 to 5 times cost increase? 4. Is it okay if the answer takes a little longer because of all the handoffs? And finally, number 5. Do you have the infrastructure to debug what is essentially a complex distributed system? If you find yourself answering no to any of these, you should probably stick with a single agent for now. And here it is, all laid out in a final cheat sheet. Look, multi-agent systems really shine when your tasks can be run in parallel, when you're willing to pay more for that extra reliability, and when you're operating at a massive scale. For pretty much everything else, especially tasks that have to happen in a specific order or need lightning-fast responses, a well-designed single agent is almost always the smarter, better choice. So ultimately, it all comes down to this one simple idea. With all the frameworks and tools we have today, almost anyone can build a multi-agent system. The real engineering skill, the real discipline is knowing when you should. The crucial question isn't can you build it, it's should you. Because you don't want to over-engineer a complex solution today for a problem that a simpler, more efficient system could solve tomorrow. For more insight on the latest marketing tech, subscribe to my newsletter on www.marketingbytes.co.uk.